Hello everyone! Time for a lesson on dividing radicals, which we're not so much doing division as we are just rationalizing the denominator. Remember, fractions are division. This says 5 divided by the square root of 2. What we're trying to do is make it so there's not a radical in the denominator. And the way we're doing that is by multiplying by 1. Right? If you take anything times by 1, you get the same thing. But we're not going to just times by 1 because that doesn't change what it looks like. It doesn't make our denominator a it doesn't turn our denominator into a rational number. It just keeps it as a radical. And so we're going to change what we times by and turn it into something that is equal to 1, but is not visually look like 1. And kind of the trick is like a shortcut, a little trick here. Use times by what this is. And it has this convenient property of turning the denominator here into a rational number. This is in fact 1. The square root of 2 divided by the square root of 2 is 1. And so when we times by this, it does not change the value of our fraction here. It keeps it the same value, but it makes it look different, which is what we're trying to do. We're trying to simplify what it looks like. And that's what's going on here. So it's got times by root 2 over 2. You do some simplifying, right? Root 2 times root 2 is root 4, and root 4 is just 2. And then on top here, you just have 5 root 2 and 5 root 2 and 5 root 2, and there you go. Problem done. And sometimes you got more things in the denominator. You still just times by this radical. And so we're not going to times by 2a root 5. You just times by root 5. And so that's what's going on in this example. Times top and bottom by root 5. So the top you get 2 root 5. On bottom you get 2a root 5 root 5. Root 5 times root 5 is root 25, which is 5. And 2 times 5 comes out to be a nice number. It comes out to be 10. And so we could stop here, but that's not as simplified as possible. And we want to keep going. 2 tenths does simplify to be 1/5 here. And I want to point out that you can only simplify the outside numbers, so the coefficients can simplify, and then the inside radicals can simplify. But this is the only radical here. If for some reason there was like a radical 10, which there's not going to be, you could reduce those like that, but you can't here because there's no other radical. And so here we go. That one's all simplified and nice and neat there. And so we're going to try this out on your paper. So we got this problem here. In the denominator, we got root 3. And so we're going to times by 1. But this one's going to look a little different. It's going to be the square root of 3 over the square root of 3. When you do this, you may have noticed there are 2 terms up here. Anytime you have a fraction there's an implicit parentheses on top and bottom. We just don't write them because it's implied. It's like the invisible ones in front of x, right? It has a power of 1, and it's over 1. It's got a 1 in front. Same thing. There's invisible parentheses around terms. I guess I'll just leave that there. Just on bottom, if there's only 1 term, you're not going to distribute there. But this one has 2 terms, and so you have to do some distribution here to simplify this problem. So we got negative 8 times root 3, which is negative 8 root 3. And then root 7 times root 3 is root 21. And on bottom here, 4 doesn't have anything in times by, so you got 4. And then root 3 times root 3 is root 9. And then we're going to simplify this thing. We could divide all of these by 3, right? Divide by 3, divide by 3, divide by 3. But now we're back to where we started, and we don't want that. Instead, we're going to simplify this. The square root of 9 is 3. And so the bottom here is 4 times 3. So the bottom is 12. And now we got negative 8 root 3 on top plus root 21. Neither of these radicals simplify because they don't have pairs of factors. But yeah, now we got this. And at this point, you may be tempted to reduce the 12 and the 8 because they're both divisible by 4. But alas, this does not have a number divisible by 4. Remember, both of these are being divided by 12. And so you can't do any more reducing here because you can't divide all 3 of these by a number just because this doesn't have a coefficient above 1. So there you go. It's all done at this point. It's been simplified. Let's go over to this one. You can follow the same path. You can multiply by root 24 over root 24. But little pro tip here, this can be simplified. And so before we do that, I'm going to save us a little bit of work by simplifying before we try and rationalize the denominator here. So we'll do some factoring here, right? 4 is 2 and 2, so we got a pair. 20 is 4 and 5, 4 is 2 and 2. So we got a pair of 2's up top too. So we're going to get 8 root 5 on top, and on bottom we're going to get 2 root 6. And we can already do a little bit more simplifying because we do have 8 over 2. And so now we got 4 root 5 over root 6. This is much easier to deal with than this root 20 and root 24. You can multiply top and bottom by root 24. You're just going to get bigger numbers, and I don't personally like dealing with bigger numbers. I like the smaller ones. So now I'm here, and I can rationalize my denominator by multiplying the top and bottom by root 6. So we got that. We got 4 root 30 over root 6 times root 6 is root 36, which is 6. And now we got this. We can simplify a little bit. Here you cannot cross those out or simplify those. You have to remember it's just the integers outside, and then the radicands inside parentheses can simplify with each other. So we got 4 over 6, which is 2/3, and then the root 30 is just going to stay there. And now we've finished that up. So there you go. There's rationalizing the denominator. But you may have noticed there's something down here. Yeah, there's more to rationalize the denominator. In order to get past that, and really we're trying to deal with things like this, we run into a little problem if we try to multiply by root 3 over root 3. Don't write this down, I just want you to see it. Once again, top and bottom have parentheses, and you're going to get 9 root 3 on top. That's not a problem. But on bottom, this has to distribute, and so you just get negative root 3 plus 3, which we have a radical still in the denominator, and we did not get rid of all the radicals in the denominator, and so we did not rationalize the denominator, and that's a problem. And so to solve that problem, you need to multiply by something that's going to make the bottom rational, and the way to find that number is you need to find this thing called a conjugate. So the conjugate is, well, if you look at this is just a couple of terms here. The conjugate of it is the same thing, but you're going to switch the operation in the middle. So 3 plus root 5, its conjugate is 3 minus root 5. Conjugates always come in pairs, and so these are buddies. They're conjugate pairs. Something like this, negative 2 root 7 minus 6 root 5. Well, the conjugate of that is going to be the same thing. We're just going to change this term here, this operation, to be plus. So now it's negative 2 root 7 plus 6 root 5. It's just, you just change the operation. One of them's plus, the other one's minus. I want to point out that this here stays negative. You don't just change all the signs, you change the operation in the middle. This negative is not an operation, it's a sign on it, and so you don't change that. So there's some conjugate pairs. So in your notes, take a moment to write the conjugate pair for this one and the conjugate pair for this one. You can pause the video if you want and give it a shot. All right, so hopefully on this first one, you got 7 minus root 2. If you did, do a little yay. That's the conjugate of that one. This one, a little trickier, but the first one still stays negative 3 root 11. And then you're going to add 10 root 6. So there you go. Those are the conjugate pairs. So now you know what a conjugate is. Now we can rationalize the denominator if there's multiple terms. Well, if there's 2 terms in the denominator. And the way it works is it looks like this. Got a couple worked examples. We got this guy here. Here's our denominator. We're going to multiply by the conjugate of that on top and bottom. So we're still timesing by 1. This is just a very complicated looking one. Root 3 plus root 2 over root 3 plus root 2 is equal to 1, but it's just weird looking. And so now the rest of the work on this worked example here is just distribution here, distribution here, distribution here, and it makes this, this kind of monstrosity here, and leads to that, and leads to that. And you simplify, you get to this conveniently enough over 1. We're going to do another example, but it's kind of what it looks like. So here we have this in our denominator. You multiply the top and bottom by the conjugate, so it's 2 plus root 2, 2 plus root 2. And you times across top and bottom. The top, you'll get 3 times on it. You got to do some distribution. On the bottom here, you have to do double distribution, so there's 4 plus 2 root 2, and then negative 2 root 2, and minus root 4. The reason you do this conjugate stuff is these are going to be opposite signs, and they're going to add out or subtract out. And that's what you want in trying to simplify or rationalize the denominators. So we're going to try this out. So here's our first problem to try out. We have 2 terms in the bottom, so we're going to multiply top and bottom by the conjugate of our denominator. So that's going to be negative 1 minus root 3. And on bottom, we got negative 1 minus root 3 as well. Since we got fractions, it's got these implicit parentheses all over the place, top and bottom. To multiply fractions, multiply tops and bottoms. So on top here, we're going to get negative 9 minus 9 root 3. And on bottom, we're going to get negative 1 times negative 1, which is 1. Negative 1 times negative root 3, we can get positive root 3. And our next one, positive root 3 times negative 1 is negative root 3. And then we got root 3 times negative root 3 is going to give you negative root 9. So yeah, hopefully you're good at your double distribution at this point, because yeah, it shows up again. On top here, nothing simplifies, so just leave as negative 9 minus 9 root 3. And in the denominator, these guys subtract out. Positive root 3 minus root 3 gives you 0. The square root of 9 is 3, so down here we got 1 minus 3. And we're going to do a little bit more simplifying. You get this, and on bottom we got negative 2. I'm okay if you leave it like this, but if you really don't like all these negative stuff, you can turn them into positives. And then we got 9 plus 9 root 3 over positive 2. Not a huge difference there, so either of those answers at the end would be okay. So is that one? In our last example, I know this has been a pretty long lesson, but there's a lot going on with dividing radical numbers. We're going to multiply by the conjugate. Pause the video and write down what we're going to times by, so you can test yourself. All right, we're going to multiply by 2 root 2 minus 10 on top and bottom. And we have all these parentheses. There is a lot going on here. And so I'm gonna kind of take this top part and put it here instead of working horizontally. I'm going to work vertically. But we need to distribute. So first part here, we got 8 root 12. And then we're going to get minus 40 root 6. And then that'll be 14 root 2. And that part will be minus 70. There's the entire top. Ugh. The bottom, we're going to get 4 root 4. And then minus 20 root 2. And then the next part, we're going to get positive 20 root 2. And subtract 100. Look, lots of stuff, but now we do the simplifying. These simplify. They're gone. They're opposites of each other, so they get 0. This part turns into just 4 times 2, which is 8. So on bottom here, we got 8 minus 100. On top, these are all different terms, but this one can be simplified a little bit. 12 is 4 times 3, and 4 is 2 times 2. So we got a pair we can move out. So we're going to get 16 root 3, and then minus 40 root 6, plus 14 root 2, minus 70. All right, there's that. And then we're going to simplify the bottom here. You're going to get negative 92. But on top here, nothing else simplifies. It's just this monstrosity here. I know it kind of looks bad. It kind of looks worse than what we started with. But in the denominator, there are no more radicals. And so we have successfully divided by our radical. We've rationalized the denominator. Woof. Yeah, so that's a mess there. Oh man, we're not actually done. Because all these terms are even. We could divide them all by 2 and make it a little bit more simplified. Not a whole lot, but we'll do it anyway, just for the sake of completely simplifying the best we can. So yeah, we're going to divide them all by 2. 35. And negative 46. All right, now we're done. But yeah, there you go. So you can't ever say, Mr. Jones didn't teach you the nothings. Yeah, so there you go. That's rationalizing the denominator, how to divide radical numbers. Kind of a long lesson, but there you go. That's the process. Good luck on your assignment. May the force be with you.